So a quadratic polynomial fits a certain pattern. And it looks like this. Ax squared plus bx plus c. Okay? Now, it could also be a combination of pluses or minuses. It could be two minuses, it could be a plus and a minus, it could be a minus and a plus. Okay? But the pattern remains the same. And I'll explain what these letters mean. You might already understand it, but I'm going to explain that in a minute. So this is the coefficient is represented by a. So some number times x squared. Okay? That is the quadratic term. Okay? It's squared. Therefore, it's quadratic. Okay? The b here is a linear term. B representing the coefficient of x. So that's x squared, that's x to the second. And the c represents a numeric value, also known as a constant. Okay? We learned a bunch of patterns already. Pull out a greatest common factor. That doesn't work. Is there a pattern? Is there some sort of a simple pattern like perfect squares or difference of squares? Or is there sums or difference of cubes? If none of those things work, then your next bet is what we're about to learn about today. I'm going to start with example 1 and I'll explain it as we go. Okay, this particular polynomial is not a perfect square because 15 is not a perfect square. It is not a difference of squares because this is not a square, this is not a square, and there's a center term. There's no common factor that I can pull out of here. Therefore, I'm left with the challenge of figuring out the factoring using a variety of means. I'm going to show you how I do it. I start by looking at this piece right here, x squared. I know that x times x in the FOIL thing that we've learned about is going to give me x squared, right? What are the factors of 15? You would say 1 and 15, 3 and 5. Okay? These are factors of 15. Now, in order to get this 15 as a negative, that means one of these factors must be negative and one must be positive. You agree with me so far? Okay. Now, here's the last challenge. How am I going to come up with the center term of positive 2x? Did you just say 3 and 5? Okay. She's right, but how do you know that? Well, in order to come up with this piece, the FOIL function, the O and the I, have to add up to positive 2. Okay? In order for that to be the case, that means the two numbers that are in this position multiplied by the two letters in this position have to add together to make that. So I am going to put my 5 here and my 3 here. And I'm going to test it to make sure I'm right. First, let's do the f. F is x squared, right? O is positive 5x. I is negative 3x. L is negative 15. Add those two together, and do I indeed get a positive 2x? Okay, what if I made this positive and the 5 negative? Does it matter? No, yes? Yes, it does. What would be different? Negative 2x. Very good. Okay, that's the difference. So not only do I recommend that you write all this stuff out, but I also recommend that you test what you think is correct. Okay? If you don't test them, then you may or may not be right. Who knows? All right? These are easy when they have these nice pretty coefficients of 1, because you don't have to worry about the O and the I's factors. All you have to worry about is these, but not factors of this. Example 2 is where it gets a little trickier. Example 2, 15t squared minus 16t plus 4. Okay. I usually just build my little boxes. Now, I know I'm going to have a t in both of these positions. Some sort of a t. But in order to have a 15, I've got to have something multiplied together to create a 15. Is it going to be 1 and 15? Or is it going to be 3 and 5? And as long as we're thinking about the coefficients of t, add to that the fact that we've got to create a 4 with the multiplication of the L. Is it going to be a 1 and a 4? Or is it going to be a 2 and a 2? How do we figure that out? How do we figure that out? Well, there is no really easy way to figure it out other than attempting to guess in the way that they have it started. You either will have 1t with 15t, or you'll have 3t with 5t. Okay? Those are the only two options that will create a 15 in the first position. Now what I need is when the O and the I get added together, somehow I will need a negative 16 as my linear term in the middle. Okay? Take a look at the top of page 189. Look at 189 with me. The variations to try out. Oh, and what am I going to have in order to have a positive with a negative linear? That means both of these have to be negative. Okay? So with a negative negative, these are the 6 options that are possible. Okay? Those are the 6 options that are possible. But in order for you to actually find the answer, you have to test each one. Isn't that fun? You have to test each one. And if you notice, the middle one, or the second from the bottom, 3t minus 2 and 5t minus 2 does indeed end up being the correct one. Okay? But this is trial and error. Okay, now there is something else I'm going to show you guys on Monday, but I don't want to show it to you today. Trial and error. After trying my 2s and my 1s and 4s, we would figure out that this doesn't work. And then over here, you would test it until you find that this works. Okay? And what you're looking for, of course, 3 times 5 is a positive 15. And of course, negative 2 times negative 2 is a positive 4. But what makes this polynomial unique is that it has a negative 16t. And we need the f, which was negative 6t, added with, or the O and the I added together to equal that. And these this one is the only option in that list that actually does that. Okay? That's example 1. Or I should say example 2. Let's go on to example 3. Just got a couple more things we're going to go over. All right. Example 3 says 3 minus 2x minus, I'm sorry, that's a z, minus z squared. First thing you're going to want to do is get this in descending degree. Since the variable is z, descending degree of z. Negative z squared minus 2z plus 3. The next thing that they suggest you do, and I agree, is factor out that negative 1, because there are no two z's that when multiplied together will make a negative z squared. Okay? So you have to factor out that negative 1, which results in z squared plus 2z minus 3. Okay, if you're not sure, re-multiply it. Negative 1 times z squared, yes. Negative z squared. Negative 1, positive 2z, yes. Negative 1, negative 3, yes. We're multiplying correctly. Okay, so now the first part of this is here. What's left is the factor for this. I know I'm going to have z's in the first position, and somehow I'm going to have a 3 and a 1 for this. That's easy. But which one's going to be negative? The 3 or the 1? The 1. Because you need to have a positive 2 as the linear term. So this, my friends, is the complete factor that you will end up with. Okay? Just like in word problems, there are some factor problems that are not solvable. They also might be called irreducible. Example 4 is a sample of what that might look like. Example 4, x squared plus 4x minus 3. Everybody see that? So I would right away start x in the first position. I know I've got to have a 3 and a 1, but in order to create a negative, one has to be positive, one has to be negative. But there is no combination that will give us a linear positive 4. This combination here, negative 1, positive 3, gives me a linear positive 2. And this combination, negative 3, positive 1, gives me a linear negative 2. Okay? I have no option to create what they're asking for. Therefore, this factor, or this polynomial, is said to be prime. Okay? It is prime. It is not factorable. It is not reducible. There is nothing I can do to factor that polynomial.